Welcome to Hope Academy. My name is Mr. O, and today I'm going to be going over the second part of logarithms, specifically towards the graphing aspect of logarithms. But before I go ahead and just teach you how to graph, especially more complicated base logarithmic graphs, there are a few things you must know in order to even graph logarithms, okay? And the part is this. The part is that if I give you any type of logarithm, so I'm going to title this logarithmic graphing. The few things you must need to know is that how does it look like along with the properties of logarithms so that you can apply these same properties to all the questions that exist. And this is the thing that you need to know. So logarithmic equations usually look like this. Okay, so logarithmic equations will look like that. It's a first thing first. When you see a logarithmic equation that looks exactly like this, the assumption is that there's a base power 10 that exists. Okay, but a lot of times they come into different formats. So a lot of times you might see them as like log 2 of x. You might see them equations that look like something like 3 of x minus 4 plus 5. They'll look different formats like this. But today I am specifically looking at these type of equations that do not have any of these extra things that are going on. So for example, like this type of question I'll be focusing on. And so whenever we see a regular logarithmic graph, we must understand that it looks sort of like this. And I'm going to provide a little sketch. So it's going to look something like this. Okay? And so there are specific conditions that are applied when we graph logarithmic equations that you must understand. So rule number one. Rule number one. For domain. Domain basically means all possible values of x. Possible values of x for this question. Or this equation. So for all possible values of x for domain, the property for domain for logarithms, at least the original logarithmic graphs, are always going to be this, 0 to infinity, or aka when x is greater than 0. So that means that this graph will never cross this y-axis that exists. So this is y, and I'll draw the little things right here. This is my x. So this graph will never cross this normally. That's disregarding the fact that if I shift this graph along the way, but for now we must understand that this graph will never cross the line, and thus why it looks like that. The second rule is based on its range. Range for this question will be negative infinity to infinity, or aka in words, it's all real numbers. That means that this graph for the y-axis will forever go down this way and will constantly go up forever. And thus why for the axis, for the range I mean, or all possible values of y, it will be y will be this case where it's all real numbers, and this is the different notations that do exist around this. Okay, but aside from that, you must also be aware that because there's these conditions like this, that means that there can never be a negative number specifically for x. That's the important thing just to note and to remember. And so that concludes sort of my explanation just around the basic properties of logarithms. And I'm going to make up a few questions, just 2 questions that will help you understand how this property works and how to go about graphing it. So right here I have right afterwards, it's just a coordinate grids. It's just to sort of help visualize this equation a little bit better, and how do I go about doing them. So for example, let's say my problem number 1 is going to be y equals to, let's say, log of, I'm making it up right now, 2 of your x plus 3 minus 2. So the reason why I chose this type of equation is because it is a little bit harder to do this type of equation, to graph it and all that. But I'm going to teach 2 ways actually how to do this number 1 question. Okay, and this is how I'm going to go about doing so. So the first way, so this is my number 1. I'm just going to call this question number 1. I'm mostly going to only focus on this question, but I'm going to show you 2 different ways. So the first way is by using logarithmic rules. Logarithmic rules. And the logarithmic rules that do exist, that in order to graph this, are based on these 2 equations. So log a of a equals to 1, and log a of 1 equals to 0. These are the two rules that I'm going to be constantly using throughout this, computation and whatever not, in order to do this type of question, to do these type of questions. So when I'm doing this graphing and whatever not, I'm actually going to use these two coordinate grids to demonstrate how I'm going to do these problems. But be aware that when I am doing these two equations, I'm going to apply a concept called transformations. And so I write these concepts out just in case you want to look them up or look into them a little bit more. But I'm going to go ahead and do so. So when I'm doing this type of questions, I'm always going to start with a parent equation. A parent equation basically is the original equation before I do any transformation, which means any shifts up, down, left, right. And so my parent equation for this equation right here is going to be without this plus 3 minus 2 stuff. So it's going to be log 2 of x, which is going to equal to y. Okay? And so applying this rule of log rules, I need to identify what my a's are going to be for this question. And if you look right here, technically my a is going to be 2. So that means if this is 2, this has to be 2, which is going to be my x. And so writing an xy coordinate grid right here, just for reference purposes, is going to be, well, if my a, or aka my x for this question is going to be 2, it's going to equal to 1. So I'm going to go 2, 1, and draw a dot. Okay. My second rule states that whatever my base value is, this part right here, aka my x right here, is going to be 1. It's going to have to equal to, for y, 0. So 1, 0. And I told you before, the parent graph original equation for any log graph will never cross this y-axis right here. And so I could sort of sketch this out. It's not perfect by any means, but I could sketch out the graph to create it to look like this. But this is not my answer. This is just my parent equation, the original equation before I shift anything else. And when I'm doing the transformation, which is the shifts, I got to be aware of a few things about this plus 3 and minus 2. So what I'm doing, and I'm going to write it right here, the log 2 of x plus 3 minus 2, I got to remember that for this case, and this is, I will create a video in the future based around this concept of transformations, I must recognize the fact that this plus 3, because it's in the parentheses that exist, it's going to be left 3. This is just something you need to memorize. And for minus 2, since it's outside the parentheses, it will be down 2. So what does that entail exactly when I do left 3, down 2? This means that according to my XY chart that I already created right here, but I'm going to show you the transition to this, it's actually technically going to be left 3. So that means I'm going to go 3 to the left this way, which also means that it's going to be 2 minus 3. And that means that when I'm going down 2 for my y, it's going to be 1 minus 2. So it would be 1 minus 3, 0 minus 2. And so for the points on here, for my new transform graph, which is going to represent this equation right here, 2 minus 3 is negative 1, 1 minus 3 is negative 2, 1 minus 2 is negative 1, 0 minus 2 is going to be negative 2. Okay, and it just happens to be the case that sort of the coordinate points look like they match up and whatever not, but it's not intentional. It just happens to be that case. So it'll be negative 1, negative 1, negative 2, negative 2. So the 2 points that used to be here got shifted and moved down here. So it will be left 3, 1, 2, 3, down 2, 1, 2, 3, down 2, like this. And that's how the points will be shifted. But a question has arisen when my students were doing these questions, and they ask me a lot of times like, Mr. O, why is it that it crossed this y-axis? You told us that it is not supposed to cross this y-axis. And that is true for the original parent equation or the original logarithmic graph before I shifted. So before I shift it, usually, and I'm going to use a pencil for this, usually there's an imaginary line that exists right here. So I'm going to shade in, looks gray. You're not supposed to cross this. But when transformations come into play, this rule actually changes. So when I shift down, this graph, this line technically quote unquote graph shifts down, but I can't shift it down. It's an infinite forever line that goes through this y-axis, so that doesn't really matter. What actually matters is this, the left 3. What this does is that it takes this y-axis value right here and shifts it 3. So 1, 2, 3. So I technically now have this imaginary line that I'm using in pencil or a shading sort of thing, and you'll see that it actually has a new line that exists right here. So what actually happens is that now I could graph this without crossing that imaginary line, or aka later on you'll learn what it is, and I could sort of sketch it out. Of course, it's not really perfect, the graph, and you could plot these points more in a different way. And thus why I'll do the exact same question number 1 right below on this grid to show you the second possible method that exists. So this is the exact sort of the graph, but let's say you're not really content. You're like, well, there's not exact points that are provided, and so I don't feel comfortable, or maybe my teacher requires me to be very accurate on my graph, and I don't want to use this method, the sketching sort of method or logarithmic rules based method. The second way you can go about doing so, and I'm actually going to write the question right here, the problem, the original problem. So this is the original problem, question number 1 that we did above. Just in case you want a reference to it, I'm going to write it right below, right here. Okay? But let's say I don't like this method and I want to do another method that's going to give me a more accurate graph. This is how I'm going to do number 2. So, or actually number 1 question. Sorry about that. But this is number 1 question. But this is the method that is called the exponential format. So exponential method or format. So I'm just going to call it exponential method so you know that this is a different way. The way that exponential method works is that I'm going to change it to an exponential format. So just like the prior question, when I identify my parent equation for the problem, my parent equation is this, y equals to log 2 of x. But there is a way for me to change this parent equation. This is how I'm going to go about doing so. So when I'm working with log 2 of x, there's a property in log that does exist. What the property does, it lets me change it to an exponential format where I could shift the 2, move it up, and what happens is that 2 of y equals to x. So this is the same thing, which will change to 2 to the y equals to x. So I could actually use an xy chart using this format, eventually apply the transformation like I did the prior method, transformations, and then get to the same graph. But this time I could actually plot as many points I want to be as accurate as possible. And a lot of my students have found this method to be a little bit easier. And so to go about doing this, I'm going to create an XY chart and I get to choose whatever values I plug in. So for example, let's say I plug y as 0. If I plug y as 0 here, 2 to the 0 power, which you need to remember is going to be 1. If I plug in 1 for the y, remember, if you notice, I'm plugging in for y to get x. So when I plug 2 to the y, 2 to the first power, it's going to be 2. And let's say I'm curious and I want to do one more. And just to work around this equation right here, so let's say I plug in y as 2. 2 squared will be 4. So I could plot all these 3 points right here. So 1, 0, so 1, 0, 2, 1, and 4, 2. So I have now 3 points. Just as I mentioned before, parent equations, you cannot cross this line, and you're going to have to graph it out, sort of like this. And so I could graph a little bit more accurately now that I have 3 points. And just as a reminder, using a pencil, as a reminder, you cannot cross this line, and I made sure my graph did not do so. So this I am good with, okay? And so that completes my graphing right here. And the same sort of method applies afterwards, where if I do the shift right here, x, y, I could shift the graph over just, as I mentioned before, as I did before. So just as much as I mentioned, this 3 will be left 3, down 2. Left 3, 3, down 2. I can do the same thing again. So just be 1 minus 3, 2 minus 3, 4 minus 3, and 1 minus 2. 0 minus 2, sorry, because I'm trying to reference this. 1 minus 2 and 2 minus 2. And what happens right here after my transformations will be negative 2, it will be negative 1, and this will be 1, and this will be negative 2, negative 1, and 0. Okay? And so all my shifts have happened. So negative 2, negative 2, negative 1, negative 1, 1, 0. So these are my points right here. As I mentioned before, the bar is going to shift 3 to the left because of the transformation for left 3. I don't care about the down 2 because it doesn't really shift a whole line down. So this shaded line, it will be here, somewhere around here. So I'm going to shade it right here just for reference purposes. And then I could graph it out. And so just to be as accurate as possible, I have more points now. And so it looks like this. So comparison between the prior method to this, you could tell that I am a little bit more accurate because now I have this 1, 0 and I didn't graph that perfectly like that right here. It was an estimation method sort of here. So I am able to graph it more accurately here. And so right here shows how I'm able to do logarithmic questions, and that's how I was able to do my question 1, or aka my log, base 2 of x plus 3 minus 2. And that concludes my explanation for today. Thank you so much for watching this video. Please do like our Facebook page or subscribe to our channel so that you could continue to watch videos like this. Please do let me know and leave a comment below if there are any other concepts or questions you may have on how I did this problem. Thank you so much for watching this video, and I hope you have a wonderful day.